You're listening to the We Are Libertarians podcast network. Find all of our shows at wearelibertarians.com.
Episode 116, The Paradox.
Welcome to The Paradox with your attending, Dr. Eric Larson. He is a practicing anesthesiologist and clinical assistant professor at Michigan State University College of Human Medicine. Listen in as he takes you behind the scenes of what practicing medicine in today's ever-changing world is like with another doctor. The Paradox is a fun and accidentally informative show for physicians, patients, or anyone who has ever found themselves in a waiting room.
Welcome to The Paradox. I'm your host, Dr. Eric Larson. Thank you for joining me as we explore the U.S. medical system in a fun and informative format through expert analysis. Today's expert is Kevin McKernan. He is CSO and founder of Medicinal Genomics and has extensive knowledge and expertise in PCR testing. As you know, PCR testing has been at the forefront of the SARS-CoV-2 or COVID-19 pandemic that we found ourselves in over a year now. And there's a lot of terminology that's used, that's thrown around: cycle times, QC, false positives, false negatives. And it's really complicated to try and find out what the truth is and what is important. And so that's why I brought Kevin on, because he has, as I mentioned, a lot of knowledge in PCRs. And I think you'll find this a really fascinating discussion. We're going to get into some technical stuff, but things that I think you can follow. I mean, frankly, if I can follow it, I think you can follow it just fine. But before we dive into today's episode, I want to share a great opportunity brought to you by my friend Jimmy Turner over at The Physician Philosopher. This is for all the physicians out there who are trying to find balance, but are overwhelmed by the daily to-do list and all their responsibilities as partners, parents, and physicians. Or maybe you are doing okay, but you want to be doing great. Does this sound like you? If so, then the Alpha Coaching Experience is the answer you've been looking for. This 12-week coaching program includes weekly group coaching and one-on-one coaching sessions, plus a course library full of self-coaching tools. It's one of the only programs with doctors coaching doctors. So if you're looking to reduce your burnout, improve your satisfaction in life, and create a life you love and deserve, don't wait. Spring enrollment is on sale now. The doors for Alpha Coaching close on February 22nd at midnight. For more information, go to drpodcastnetworks.com/alpha. That's drpodcastnetwork.com/alpha. As a reminder, you can go to theparadox.com/116. There you can find show notes to today's episode. We reference a couple episodes from previous times, so studies and JAMA. Also, for those of you who have not yet subscribed to the show, please click the subscribe button in your favorite podcast player. That way you don't miss any exciting episodes as they come out. It has been weekly all this year. I intend to be keeping that schedule for the rest of the year, which I credit to the Dr. Podcast Network for helping me stay on schedule and providing logistical support. You can check them out at drpodcastnetwork.com. Also, to all the patrons at patreon.com/theparadox. There you can become a monthly supporter for the show for just as little as $2 a month. It provides the financial support to help the production and promotion of the show. And I'm tremendously thankful to all of you who leave reviews at 5-star reviews so far and written reviews on whatever podcast player you're using, and also recommending it to your friends and family. But without further ado, Kevin McKernan and PCR testing for COVID-19. Enjoy. Hey, I'm here with my new friend, Kevin McKernan. Kevin's a CSO and founder of Medicinal Genomics. He has a BS in biology, a focus on cloning expressing norepinephrine transporters from Emory University. But since then, he's done a lot of work in PCR and testing. And that's really what we're going to talk about today. Your company does a lot of things in testing, and so we're going to talk about PCR, which suddenly everyone, it's become a sort of household name for whether you're in science or not. Thanks for joining the show.
It is. I don't know whether it's become a dirty name or a good one as of late.
Well, right. And I think that's a good point. I like most things with SARS-CoV-2, I think, things become sort of, social distancing. No, that term didn't exist. I mean, there are lots of things that add to the vocabulary. It's like an urban dictionary in some ways, right? That comes up.
Yeah, it's true.
Well, let's talk about PCR. And PCR is short for preliminary chain reaction, which is a test. And so why don't you just give us a background on what a PCR is for both our clinical and non-clinical friends?
So it's a very sensitive test that amplifies either DNA or RNA. and it's sensitive down to a single molecule. So it can pick up this virus when it's mid-infection, when it's pre-symptomatic, and even probably 70 to 90 days after your symptoms have subsided. So it's very good at tracking down where this virus is, but also where it was in many ways. And I think that's where a lot of the confusion comes about in the discussions about false positives. What is a PCR false positive? Is it picking up the wrong virus? I don't think that's happening very much, actually. I think that most of the PCR tests out there are really specific to the virus at hand. There's a couple early ones that weren't as specific, but most of that's been addressed since then. I think the real challenge with PCR is that it's not necessarily predictive for who is infectious. It can tell you if you are infected or were infected, but it doesn't tell you if you have live virus that is viable and transmissible to another person. It's been used as a pandemic tool to track this because of its sensitivity. The FDA has kind of held that bar on sensitivity against all tests, and it's been very difficult for other tests, particularly home tests, to get cleared because they're not as sensitive as PCR. And I think that's actually a real shame, because I think the home tests would really radically change the course of this. It's much easier to be taking tests at home than to be centralizing all these people into lines at testing centers where there's a chance of actually moving infections around in line. So yes, PCR is a very sensitive test that measures the virus. Since it's measuring RNA, it is not measuring the protein code. It's not measuring the spike protein. So it can't really discern whether the virus is fully intact. It can just tell you that you had a piece of RNA highly similar to SARS-CoV-2 in your body.
And so the RNA codes for about 1,200 proteins, I think, in the...
Oh, no, it's 30,000 bases long.
Okay.
And I think the number of proteins it has, it's a very interesting virus in that it expresses a very long polypeptide that then gets cleaved into pieces. And I think it's more like 14 or so. I could have that wrong. It might be upwards to 30, but I don't think it's that long, or that it's not 1,200. There's actually like 9 pieces of this genome that get highly expressed once it's in your cells. They're called subgenomic RNAs, and it makes a lot of those. And many people may have heard of one called the N gene. That one's the most expressed one, and that's the one they tend to target a lot for these tests as they go after to see how much of that N gene is made. The other gene a lot of people hear about is the spike protein. That's one that the vaccines actually intend to express. They have about, I think the Pfizer vaccine is 4,200 bases long, and it's expressing mostly parts of the spike protein with a couple other accessory peptides in there. And that's meant to trigger your immune system to get sensitized to the spike protein.
When it comes to the testing, kind of going up in different directions here, but let's go back to PCR. So my sort of simplified way of thinking about the PCR is essentially it's a way of magnifying presence of some sort of the RNA or the DNA that's present, right? So we have a very small sample, like you said, we have a molecule. Ordinarily, you can't detect a molecule of anything with any sort of test, but the PCR by various, we'll just say means, through various cycles, can continue to amplify what you're looking for. And so hopefully by a certain point, whatever you're looking for expresses itself on your test. Is that kind of accurate way of looking?
Yeah, that's correct. And this is, and your statement about single molecules was true for a very, very long time. Recently, they have come out with single molecule sequencer. They're probably not best fit for this purpose just due to expense and portability and all those things. But those are, I think you'll see more of those. There are things called Oxford Nanopore and Pacific Bioscience sequencers, which can now sequence single molecules. It's an absolute revolution in the field. And they're getting deployed in the sequencing side of tracking the pandemic, but they're more expensive. And what people use to track millions and millions of tests is PCR, because it's so cheap and small, and it is very sensitive, and then it picks up these single molecules, but it amplifies them in order to see them. It doesn't read the single molecules directly. It makes Xerox copies of them over and over again. So there's enough of them that they can cheaply track them with fluorescence. And they look for a fluorescent signal to build up over time throughout a PCR reaction. And this is where that cycle threshold number has come into place, is that's the number of duplication events, how many times you ran the Xerox machine before the fluorescence reached a particular threshold. And that threshold is something that the labs can change a little bit. There's sort of a background threshold they can adjust a little bit. And then there's also how many cycles do they deem to be a positive event. It's usually around 37 in most labs, but I think that's created a lot of confusion on the internet, actually. You'll hear people complaining about tests that go up to 40 or 45 cycles, but people usually aren't calling out at 40. They're running their camera out 40 cycles because they need to be able to see a few cycles past where they actually call the point at which the peak comes above threshold. So don't get too distracted by that. I mean, when you do see tests that say 45 cycles, it's a sign they had to run more cycles to see some of the virus come up. And that's usually a red flag that the test is a little bit compromised compared to others. But it's very rarely the case that the labs are calling like at 42 or 43. They're almost always calling below 38. But even at 38, there's many publications that will show you that very little of that virus is actually replication competent. It can't culture itself in vero cells, which is the kind of the standard people use, is they put these monkey kidney cells into petri dishes and see if the virus can actually replicate there. And it's very rare you see anything after cycle 33. I want to be careful in talking about these cycle numbers, is that all the tests a 33 on one test isn't identical to a 33 in another. So there's some calibration between them, but they probably only shift a couple cycles between the different tests. So we can't take this universal 33 number and throw it across the globe. That's what a lot of people have been asking the World Health Organization to do, but they've wisely stepped away from that, saying that's a little risky. Look at your test specifics at the FDA and under the emergency use authorization documents to know where your limit of detection is. Your limit of detection is the point at which your assay can no longer pick up molecules. And it's usually the tests are about 5 to 50 molecule sensitive for picking up RNA viruses. They don't get all the way down to a single molecule for a host of reasons, but there are highly specialized DNA amplification tools that can pick up single molecules. They're just not deployed on this, and they're perhaps a little bit oversensitive for the needs. But I'd say if you're on those swabs that you take, the entire swab that goes in your nose or in your mouth doesn't end up in your PCR test. Probably a 50th of it ends up in the PCR test. So if you have maybe 500 molecules on that swab, the test will pick it up late at 37. If it's below that, they may not see it. But that is probably the biggest variance we have in all of PCR right now, is the swab. It can vary 1,000 to 10,000 fold in how much comes out, which means interpreting the PCR results, it's really dependent on knowing how much you got out of that swab. The tests here in the States, at least the ones from the CDC, have a very important internal control that measures a human gene in the process, so they can calibrate how well did your swab work. If nothing comes off, if you don't see any human gene signal, you know the swab just missed and it's a dud. But if you see a high amount of that human DNA, human RNA, you will know that you got a very good sampling and that you might need to discount the viral load a little bit. I don't think a lot of that normalization is happening right now in the field. They're just looking, is a human gene there or not? If it's not there, it's basically a non-informative test, and they try to repeat it. And if it's there, they'll move on to calling whether it's, hopefully below 37. But it's really important to have those internal controls. They're not present in all the kits. In fact, in Europe, there's one kit that I've been quite outspoken about people changing it, is that they don't have that internal control. And it makes it very difficult for them to put a CT cutoff for who's in fact has viable virus and who doesn't, because I think that's critically important for the patients to know, the doctors to know, mainly because in many jurisdictions, we're doing these tests without physicians involved. So we're calling medical cases kind of blindly off of a test, an amplification test that's easy to contaminate. And without symptoms, I think calling medical cases and quarantining people sort of crosses some ethical lines, and that there should be a secondary test or something else to confirm the event. That's a long-winded way of saying that there's a lot of complexity in how we call these PCR tests, and I wish more physicians were involved.
Yeah. There's a lot to unpack there. So I guess, to summarize things, you'd say that there are cycle times on average, once you hit below 33 on average, you're getting you're probably getting a sample that doesn't contain viable virus, one that's actually active within the host, probably.
Yeah, I'm sorry. I meant it's after 33. The right. Scale is inverse. So the more cycles you need, the less initial material you had. So if your sample amplifies in 20 cycles, you had a ton of RNA to start with, because your Xerox machine only needed to run 20 times to make it come above signal. If you have to go 40 times, you're having to run that Xerox machine so many times that you're just picking up noise. One way of estimating the magnitude of this event, every cycle is a doubling. So you can put 2 to the power of the number of cycles that you do, and that gives you kind of a sense of how many times you had to amplify it. So 2 to the 30th power is a very large number. But about every 3.3 cycles is a 10-fold difference. So a 30 versus a 33 is like a 10-fold difference in the amount of RNA. That's kind of a general guideline on what these numbers mean.
Right. Basically, if you have a low cycle threshold, you're saying that the likelihood of you getting a positive culture, not that people culture very often respiratory things, that it's a little higher, right?
Yeah, it's much higher. In fact, a good paper for this is from Rita Jaffar out of France. And you're right, people can't culture these things on every test because, one, the cultures take a long time, and nobody likes to have a factory of replicating, right? It'd be a hot zone. So they do it once to calibrate the test, and then they never do it again. But the calibration is really important. I mean, on all PCR tests, that's the gold standard, is you want to have the CT values calibrated back to replication competent organisms. Otherwise, you're kind of have a number in space, and you don't really know what it means and whether it really guides any clinical outcomes.
Right. So what's the term CQ? I see that oftentimes thrown about as well. What's the difference in that and CT?
So I'm glad you brought that up, because CQ is actually the more proper term according to the MIQE guidelines. Stephen Buston authored that paper, but they get used interchangeably with CT, and it's an artifact of early in the PCR days. There were some patents on different techniques, and of course people had to name things differently to try and dance around them, but cycle threshold and cycle quantification are interchangeable terms.
Okay. It's very similar to EKG and ECG, right? It depends if you want to use the German spelling or not.
There you go. Right.
And so I think, important thing you mentioned is the logarithmic nature of it, sort of the mathematics of it all. How many times you press the zoom button on your computer to get focus in on some of your photo, the more time you have to do it, obviously, the smaller it is, whatever you're looking at, right? And so, right. Exactly. And so, but it's a doubling. And so 2 to the third, every 3 cycles, about 8, right? So that's why it's about, is that kind of how you get to sort of like almost logarithmic, right? Every 3.
Yeah. So it's at 3.3 technically is a 10 log. So we go in units of 3.3 on the 2 log scale. But
and so then one of the things I saw earlier on is you'll see a nice downward slope. I think it's downward slope of amount of virus based on your cycle threshold, but that's always graphed in a logarithmic fashion. So it looks like a kind of a nice smooth line that's fairly flat. And then when you see it, when it's actually not flat, you see a massive spike in virus at one point, and really not much after that. I mean, if that makes sense.
Well, are you referring to the sort of the course of the viral load in the patient?
Yeah,
over time?
Exactly. Yeah. So you'll see threshold
long tail. You're right about that.
And even early a little bit, but not quite as much, but definitely more long tail than early.
There's kurtosis in the tail. And that's actually what drives us nuts is that the front end of the curve is really steep. It replicates very quickly upon infection. And that's actually an important piece of information. If we were actually testing at 2 different time points with PCR, we would know that you're in the front end or the back end of the infection, because it grows so quickly in the front end and it clears so slowly in the back end that you would see a very subtle change in the CT value 24 hours apart if you're clearing the infection, and you'd see a rapid change. And in PCR lingo, you'd see actually a decrease in the CT value, because lower CTs mean there's more virus. So you would see the number go down on the scale on the front end, and you'd see it actually go up on the scale out toward 40 on the tail end. And if we had the wherewithal to test twice less people, we would actually know whether you're pre-symptomatic or whether you're clearing this. And I actually think that's the real key to opening up society, is that because I should point your audience to a paper that describes some of this. It's called LIOTTI, L-I-O-T-T-I. It's in JAMA. And what they do is they measure the PCR course of infection, and they show that people are infectious for about 7 days. And they show that they're PCR positive. One patient out there was out to 77 days, but it was 172 patients in that study. And I think it was about 46 or 47 days on average, they were PCR positive. So you're PCR positive. If you're PCR positive for 47 days and you're only infectious for 7 days, there's a lot of quarantine potential of people who aren't really infectious. And I think that's the problem that occurs when you run into a seasonality like this. You get into the wintertime, and suddenly you get lots of people that are positive and everyone freaks out on the news, but we don't really have good time resolution on how many of those are recovering and how many of those are pre-symptomatic and infectious. This is where I think a lot of those rapid antigen tests can really help out, because they're much less sensitive, and they're looking for spike protein. So they're much more reflective of the patients that are truly infectious. It'd almost be better if we use those to confirm PCR.
Yeah.
Or maybe just started, when you go into asymptomatic populations, maybe that's the better tool, because one, it's cheaper, it's a little bit more portable, And it's not going to flag as many people that had the virus a few weeks ago. And then suddenly you contact trace map that entire family unnecessarily and sweep in a lot more of this testing. I don't think there's a lot of financial motivation, unfortunately, to switch, just because the contact tracing is in fact a testing vacuum. It brings in a lot more samples. And so when the positivity goes up, the testing labs get flooded, and the contact tracing they like positivity because it brings in more of the family members. If you had a test that actually cut that off, it would probably lower revenues for them. There's a little bit of, I think, a battle in the marketplace right now with PCR versus rat testing, and you can see a lot of those fights on Twitter. But I personally think tracking the infectious folks is most important, because there is an impact on hospital care. If everyone's suddenly positive, but they're asymptomatic, or they're positive because they had it a few weeks ago, you start to lose, if not the nurses, you lose some of their family members and their kids. And there's all types of displacement for people trying to staff the hospitals when the tests are overly sensitive and picking up past infections.
Yeah, no question. And we'll see it in surgery, because we require PCR tests before every surgery within, I think it's like 72 hours for elective surgery. And so there are a number of people who...
That time is a real problem, because what do you do in those 3 days while you're waiting? You can't live in a bubble.
Well, no, I mean, so this sort of exposes the problem with any of these sorts of regimens that you sort of processes you put into place, right? So we'll have people have to have a test within three days, 72 hours. If it's positive, their case gets canceled. And let's say they're asymptomatic, their case is canceled for 10 days and they reschedule. If it's negative, we just go ahead and go. And then there's, of course, on the day of surgery, are you asymptomatic? Do you not have symptoms of respiratory problems? If not, then we just go ahead and go. Now, you could argue you could be infectious during that period. I mean, you can never catch someone perfectly if you're not testing everybody every day, right? And so there's always a risk. I guess you'd argue that, well, you're catching some people, but to your point, we don't really know when people are infectious. And this is the problem, because I think fundamentally PCR, as it's used now, is a qualitative versus a quantitative test, right?
You're right. Yeah, these got rushed out under qualitative guidelines, and we're looking to do quantitative assessments with it, and that is part of the challenge. There's a lot of people and I've been pushing to get the quantitative information out, because I think that's the only way to answer that question, is to look at CT values and know that, all right, if you have a patient that needs a surgery, like an appendectomy or something, it's kind of urgent. If the CT value is at 37, that's probably safe to continue. You're probably going to do it anyway with an appendectomy. Maybe that's a bad example.
It's true. Actually, I have done that specific case, actually.
Yeah. So bad example, but something else that maybe not as urgent, but you may not need to hold it up for a 35 or a 37 CQ. Now, do you have to test your staff as well? Did they get dinged by these?
The answer is no. What we do is we survey people. So we do all the things, check temperature. Are you symptomatic? If you're not, have you had people who have exhibited symptoms that you're living with who've had positive tests, those sorts of things? Then you get yourself tested. A lot of my partners and lots of people I know in the nursing staff have been tested at some point or another, just because, nowadays you can't get a cold and just show up to work. And now you get a cold, it's like, well, it might be SARS-CoV-2, it might have COVID-19, so I bet I've got to get a PCR test, right? And and then you're waiting for the results before you can come in. So we've had a lot of people who have been sidelined for a day or so. I mean, our turnaround's usually pretty fast, except when it got really, really busy. And then we're having delays of 5 days getting results back, which makes it pretty much clinically useless.
Yeah, because you can't, by the time you get the answer back, you don't know what's happened. Yeah, we experience that as well. We're in more of an agricultural testing arena, and we're often put up against culture. I mean, in the culturing these things, and some of the yeast and molds can take 5 days to 10 days to grow. And so by the time you actually get an answer, you've got to question what's now growing on the product after I got the test back.
Right.
So there's that time delay is a real issue. And it's really not an artifact of PCR. It's an artifact of centralizing the PCR, because you can get an answer from PCR in an hour. I've seen some people do it in 20 minutes with some really fast cyclers, but trying to get all those swabs coordinated and centralized in a few laboratories and run is, I think, where these time dilations are occurring. The rat tests offered, they can do this in 20 minutes and they're more portable than PCR, but there are tools out there that could do PCR in a more decentralized fashion. They're just not through the FDA yet. I think the FDA has maybe allowed one or two out the door, but there's a lot of folks banging on their door right now to try and get the home tests out so that you don't have this long wait. And then if they're cheap enough, you can run them twice, all right, that if you run them twice, you get rid of the whole false positive concern, because
Right.
and you can also maybe, if there's at least some level of quantitation on the test, you can see if the viral load's changing between the two tests, and that can be informative as well. But I think the home tests, not all of them are going to be quantitative. They're mostly going to be qualitative, where they're just yes/no answers. That's still very helpful. That could still, tremendously screen out the number of people that are waiting around for a test. And I agree, if it starts pushing beyond 4 or 5 days, it's not a very useful, very practical tool, because what do you do in the meantime while you're waiting?
Yeah. Well, I mean, that's been the problem. And I would even argue once you get to about 3 days clinically, it's almost useless, because you've probably infected anyone you're going to infect at that point. The whole family's, you've got,
Right.
you cause a real problem. You're not able to adequately, it's not realistic to have in families to quarantine people for multiple times because they have kids who have, come back from daycare with a runny nose. And
Yeah.
what are you going to do? So it makes it real complicated. Can you briefly just talk about, you hear people say, well, if you run a PCR long enough, you're going to get a positive, right? If you run enough cycles. So is that just briefly just kind of like noise that eventually just shows up?
Eventually the primers will bind to themselves. So the way PCR works is there's usually 2 primers, which are about 20 letters long. And that's kind of the address for what part of the DNA you want to amplify. And those should be very specific to the virus and not have any cross-reactivity to the human DNA or the human RNA. And they shouldn't cross-react with themselves either. If they can bind onto each other, then you can get weird amplification signals that come out, past 40. That is the case in a couple of the kits that were first raced to market in Europe do have some of that capacity. And it's been we have a paper out that's documented, about 20 different papers that show some of these primers interacting with themselves. And it can decrease your sensitivity, and it can also create some false positives. But, those are usually things that are occurring out past 37, past your limit of detection. And most of that noise should have been screened out with the tests that have been thoroughly validated. But there are some extreme examples where people report they've put kiwis in there, or some other DNA that the manufacturers they can't test these things against everything under the sun, right? So there may be some extreme genome out there that shares some of these sequences, and it tends to light up on them, not perfectly, but maybe very, very late in the process. There's certainly some examples of some of the earlier tests that were amplifying in water. The negative controls were lighting up too frequently, and that's a sign the test probably needs to get refactored a little bit. But I don't think that's the dominant cause of false positives. I don't think it's a primer issue or a sort of a specificity issue, like hitting the wrong stuff. I really think the predominant false positive debate that's going on is really a misunderstanding between a clinical false positive and an analytical false positive. Analytical false positives would be, okay, your primers did something like that. They misbehaved, they landed on themselves, or you ran it too long and you got a signal that's late and probably analytically incorrect. I think the bigger issue is really splitting hairs between people who are on that long tail of positivity, where they're no longer infectious. They truly had the virus, but it was a long time ago. And there's enough remnant RNA around that you're picking them up and quarantining them. And many medical ethicists will say, well, that's a clinical false positive because you're quarantining somebody who's not infectious. And the test is calling medical cases without medical supervision. So it needs to be held to the standard of a clinical false positive. So I think that's where most of the debate is probably misheard in the field, is a lot of people just think they're running 45 cycles, they're irresponsible. But I really don't think there's that much of that going on out there. It's really more of people just not calibrating the test to replication competent organisms. There's maybe a dozen papers out there that have done that. And I don't think you don't see that in the FDA documents. The emergency use authorization documents don't require that step. Most other clinical tests, they do. I just think under these emergency circumstances, they cut that part out because no one really had access to the virus until much later in the pandemic. ATCC finally got versions of the virus available for people to purchase that were attenuated, but they didn't have it early on. It was they were having to design these things off of a DNA sequence that was emailed to them from China. So it was kind of a race to get out the door, and there were some errors on the front end of it.
I think it's probably important to point out that when we talk about, and it's why the term cases is not the right.
It's a bad word. Yeah.
It's a bad word, but maybe it's accurate. Maybe it encompasses everything of people who have at some point been positive, but doesn't necessarily mean that you are actively infectious or sick.
Right.
Right. And so that's the tricky thing. So would you say it's fairly safe to say if you have a positive PCR, you have an infection, or you recently had one, and recently within the last couple months?
Yeah, and I guess I'd have to leave it, defer to you on the definition of an infection, because yes, the RNA is there, but there's a lot of asymptomatic infection, I guess, with this virus, and so some people don't even like to call cases on people that are asymptomatic because they've not presented a medical condition per se, right? So there's perhaps some terminology. Maybe we need new terminology here, which is, you're RNA positive, but you may not be infectious and you may not be a case yet, but we're calling every positive PCR right now a case. And I think that's where a lot of the misunderstanding is coming into play.
Yeah, well, and when you look at HIV, we have people who are considered infected with HIV and are positive,
but
but their viral load is so massively low with medications now. They're asymptomatic. I mean, they're pretty much fine. Now they're in that condition because of medications. But I think probably in some ways it's somewhat analogous. I mean,
it is. Yeah. It's transmitted differently. So I understand there's perhaps, I don't know at what viral load in HIV you can still, it's still sexually transmissible or transmissible through blood, but that's, it's a similar analogy, it's respiratory in this case.
Yeah. And I think overall, when it comes to SARS-CoV-2, it's really hard, primarily, I think, because we don't really do it with anything else, many other infectious diseases that I'm aware of, where, I mean, it's entirely possible that we have asymptomatic carriers of all sorts of things.
Absolutely.
Well, I mean, we know we do this, right? We absolutely know we have people who are colonized with, say, strep pneumonia, and, they or strep B or something, right? And they walk around all the time and give other people strep.
Yeah.
They're asymptomatic. They don't. In fact, I know someone personally, my wife, who was one of those people. My son kept getting it, and of course, she's a pediatrician. She assumed for some reason that I had it and that I was the carrier. And so she's like, "We better make sure no one in our family has it." So we all did the big, huge, throat swabs. And of course, she cultured positive, but we know that happens. I'm sure that happens with viruses. I know I've talked to my friend who I spoke in the last episode, Dr. Graham, and he said, you culture any daycare kid and they're going to have a number of respiratory viruses asymptomatically. They're in their nasal pharynx.
Right.
And that's how they transform a lot of adenoviruses or coronaviruses. And that's just a thing.
Yeah. It's an interesting point that this coincided with us really turning on genomics at a population scale. And so now we're seeing these waves for the first time and we don't know how to interpret them, right? We're seeing these large spikes in positivity thinking the world's going to end, but it's like, that's actually seasonality of the virus that we're watching in real time. And it may not perfectly translate into hospital load. I think that's something we're all learning this year is what level of PCR positivity is actually predictive of hospital overflow. Certainly the numbers going up isn't good, but it doesn't necessarily translate into deaths. So I worry that we could repeat this with OC43, for instance, another coronavirus that's seasonal, that travels. It's less symptomatic than SARS, than C19, right? And if we were to hunt that around, I think we could easily create a media narrative of panic tracking that around as well, because it does take out some elderly. There's some cases of OC43 hitting nursing homes and having like an 8% fatality rate or something. It can actually be quite high in the elderly. It's just not novel and out of China. It's been around forever and it's less severe than SARS-CoV-2. But I wonder if we had turned our eye onto that thing with all this PCR capacity and tested the world asymptomatically, if we could have driven ourselves into a state of panic and shut down as well off of something even more benign.
Yeah. Well, I think, the element of what you do when you do it, and it makes it a lot more challenging for people. And the fact that it's novel, as you mentioned, makes a big difference too. But I think I don't think anyone can credibly say that SARS-CoV-2 or COVID-19 is not a real disease process. It's not really a pandemic. It's definitely spread over the world as people are getting infected all over the place. And it is definitely killing lots of people.
Yes.
The question is, how do you track it? Who's at risk? How do you sort of protect people?
Hey, triage.
And how triage. And I think, fundamentally, if we looked at OC43, I've discussed this in my show before, probably 1870s across from cows. We're not sure. Sometime around then is the suspicion. And it wouldn't, at that time, travel around the world as quickly just because of travel.
Exactly.
Right? It'll be a slow sort of burn across the world.
I actually like that. Sunotra Gupta has a really interesting take on this, and that human immunology has vastly improved since we become hyper connected, and that might actually be the reason why we have longevity improvements in human lifespan, is because there are no longer pockets of the world that get hit with smallpox and get wiped out, right? Because smallpox we've dealt with vaccination, but there just aren't these pockets that are immunonaive to particular variants or particular strains anymore, because we're traveling so much, we're sharing these things around, so all of our immune systems are getting hyper stimulated to the point where we don't have a blinded exposure, if you will. So I found that really fascinating, because it seems to resonate with lifespan increases, and perhaps it sheds a different light on immunology. The concept of isolating everybody may actually bring us back to a point of having subpopulations that forest fires that can occur, because we remained outside of the germ pool for so long, and we hide, and then next thing you know, a real tough variant comes through, and our immune system hasn't had that little upgrade from the most recent variant, and so you get hit with something that's much more distant because of your isolation. Yeah, there's a lot to unpack here, I think, from a global immunology standpoint.
Yeah, a lot we don't understand. I mean, I think there are so many black boxes that exist within this SARS-CoV-2. We see young children who are essentially not susceptible to this. We don't have any explanation for why the young are, right? I mean, is it because they're living with coronaviruses, left and right all the time, and so that provides some innate immunity to it, some T cell immunity? I mean, clearly you see that as you get older, you're more at risk because it's a new variant, or I shouldn't say variant, it's a new virus entirely. It's right, and so there are people who clearly have some sort of innate immunity we can't explain, but the elderly are much more at risk because they have not seen it. I mean, you wonder at some point if it's very similar to like when OC43 came across, that all the young people got it. The old people, probably weren't as many old people then, probably not as many people who were obese, who had higher, risk for things.
Yeah,
and
metabolic disease.
It knocked off.
Yeah.
Right. It just knocked off some people, but there weren't as many people to maybe kill. It didn't spread as quickly, obviously, because of world travel. Anyway, and then those generations, and from there on, everyone just has an endemic coronavirus, and they're just sort of exposed to it when they're a young child, and it's not a big deal. It causes a cold.
Yeah.
I mean, I think there are many things like this that I think we don't think about. We know, but we don't think about sometimes. Like, for instance, if you get varicella, chickenpox when you're a kid, well, you get chickenpox, you're pretty terrible. You feel awful for a week or two or something. Super highly contagious, right?
That one can remain dormant for a while, right?
Yeah, you're okay. Now, we do know about shingles and other things that can happen later, which we are associated with varicella. But if you're 50 and the first time you're exposed to varicella, it can kill you.
Right.
Like, I mean, there's no, right? And I think, that could be a little bit of what this is. It's sort of like your old people with immune systems that are sort of set, cannot adapt as quickly, maybe. I don't know. We don't understand this stuff, but that it may be a lot of that, right? It's just like and there's nothing you can do about it, except I think a vaccination is a helpful thing in the sense that I'd rather have a vaccine be my first exposure to this virus, and to develop an immune response, and then I'm going to experience in the wild probably a couple more times as it just keeps circulating around.
Right. My only reservations on the vaccines are just the speed and the QC. Right, we've got great sequencing being done on a lot of these coronaviruses, so we understand the variants and the whole flux of them. What I'm somewhat shocked by is I'm just not seeing any sequence QC on the actual mRNA that's in the vaccines,
Quality control, you're saying, right?
Yeah, I would love to see those sequenced as readily, just to know, because I know from manufacturing long RNAs like that, it's not a single sequence. It's just there's error in the process of making RNA like that. And so there's going to be a mutation profile in those vaccines. They might be very low percentages and small heteroplasmies, not maybe nothing to worry about, but it's not expensive to do anymore. With sequencing costs these days, they could be sequencing, every 100th vaccine that's given out if they wanted to, just to see, okay, what's the manufacturing QC like this? And I think they're just getting raced out the door so quickly. That's not happening. There's also not a lot of liability on them. So I worry that without the liability, there isn't a motivation to do extra QC. But I would love to have a catalog of that, just to know, are there particular variants that are in these vaccines that might be, something should we have a record of those, just like we have a record of the mutational profiles moving through on the virus side, just to know what epitopes are actually getting exposed to humans. The main region in the spike protein that I think causes the most controversy is the Staphylococcus enterotoxin B domain. This is an SAB domain that's really hyper. It can drive cytokine storms. And this is the area they think's involved in a lot of this antibody-dependent enhancement and pathogenic priming. And it's the area where I think they're most worried about long-term effects of the vaccine, that if you get the vaccine and you see coronavirus again, a small percentage of those people have a bad response. And we don't understand it, but it's what's kind of held up. Peter Hotez was actually quite vocal about this early on. He's a vaccine expert down at Baylor, that ADE has always held up other cold vaccines because they just, in animal models, they have a really hard time with this and they don't understand it. But I think we want a catalog of these things, of these variants, to know if any of those, if there's any rare errors in the synthesis of the vaccine that might be in that SAB domain or other critical parts of the protein, that we have some understanding of those too. But I agree with you in general. I like the idea of not having the whole virus in me if I'm going to first be exposed to it. I'd rather have just a small piece of it so it's not replication competent. That makes a lot of sense. And I think this messenger RNA technology is incredibly powerful. Like it's clean in terms of, the earlier vaccines that the world lived with, they had to brew these things in other organisms and other cells and all types of other, like SV40 came through in one of the earlier polio vaccines, right? So there's a host of complications that occur when you have to make these things in cells that just don't exist in mRNA vaccines. They can be incredibly clean, and that they're purely synthesized, and we can QC this thing beyond our dreams that we could ever QC a vaccine before. So it's a really promising technology. I just hope we don't hit a pothole on the way because we're rushing it. Somehow it gets egg on its face, no pun intended, because the flu is growing eggs.
Right. Yeah.
But because of this, because they've raced it so quickly, but because I don't want to see that technology get bruised in the public opinion. Yeah. Because it can really revolutionize things we're doing.
Well, and I think, with all the variants that are appearing, and I don't like saying it that way because it makes it sound like variants are a new thing with SARS-CoV-2, but it's, as soon as it hits anybody, it starts mutating, and when it gets in larger populations, you're going to get more and more variants. There are, 10,000 variants they found, and only a couple of them are important enough to actually make note of. Yeah. Which, now there's another one in California I just read the other day. I mean, I'm sure they're all over. So I guess the one question is, with the PCR testing, do they just look for a small sequence? Are there going to be some of these variants that potentially would evade the PCR test?
You hit on a really important point, because now they're starting to track all the different frequencies of those variants amongst the population to know which primer pairs are in fact impacted by these. And this happened to the UK actually. They were using an assay known as the tag path assay that, unfortunately, it was targeting the S protein, and there was the B117 variant happened to trip that assay up, so it was failing to detect those particular viruses. Now, for this reason, we prefer to have multiple different targets in these tests. If we just target one region, that can happen, and you can have blanks and not know about it for a long period of time. What they do is they usually target the S gene, sometimes the N gene, sometimes the E gene, sometimes ORF1AB. Ideally, you want 3 of these because it's mutating at such a rate that you need to have at least 2 of them light up, and you can afford for one of them to fall through. And that's kind of what they've resorted to in the UK. However, what you'll notice is when the summer comes around, the assays start to drop out anyway. Only like the N gene and a couple of the really highly expressed genes stick around for the summer. And so you start to see in patients, the number of patients that are testing positive for all 3 genes will start to decay in the spring down to 2 genes, then down to 1 gene, then down to 0. As you come into the summertime seasonality of it. So I do think it's important that there's at least 3 of them, and that they should be spread out all over the virus's genome, because there's differential RNA expression on one side of the genome versus the other. And if you only put them on one side, you might be measuring non-replication competent virus. If you just measure the 3, for instance, the 3' end of the virus sticks around the longest, and you can get signal there, not necessarily have replication competent virus.
And you mentioned earlier about the antigen tests at home. My understanding, and you probably know the answer to this, is that actually antigen testing for home use, meaning like the spit in a cup sort of antigen test that people could potentially do, or their own nasal swab, I suppose, that technology was actually present right at the beginning. We're talking March or April of 2019, and that it was that technology was sort of squashed by the FDA and the CDC because it wasn't sensitive enough, and they said we're not going to allow this sort of thing onto the market because we want to have trained professionals to do it. And it probably put to the point where, because of the centralization, as you were talking about earlier with the testing, where they're just, much like we have problems with the vaccination distribution because it's all somewhat centralized, partly because of just the nature of the vaccine where it has to be in those freezers and stuff like that. But that it sort of made it a lot harder to get any sort of handle on where the virus was and how prevalent it was.
Yeah, that's true. It had that time effect is when you centralize them, it turns into a 3 or 4 day process as opposed to getting an answer that day in your house. And I actually think there's a risk in the more you centralize, the more you're concentrating people who think they have the virus with people who have it. And so I mean, I know here in Mass, I remember going to one of the testing centers and they had all of us line up in the same line, asymptomatic and symptomatic in the same line. And they didn't triage them like and test the symptomatics first. So 1 o'clock rolled around and they said, we're closing up for the day. We don't test after 1 o'clock. And it's like, everyone go home. It's like, well, you could have run all the symptomatic people in the morning and not, just simple things like that I think get, that can increase the risk of spreading this by centralizing it. So, and you're right, the technologies were available, and the FDA in general, they get very nervous at direct-to-consumer testing, and I think they just were afraid to let that out of the gate. But I think it would have helped tremendously in the pandemic had they done so. There would have been less quarantine going on, and probably less people congregating at clinics and hospitals where. If you go to the hospital, there are higher rates of infection in hospitals because you got a lot of sick people there. So,
right, turns out
it's not necessarily the best place to be waiting around for a test. So the remote clinics are very helpful, but a lot of these things got thrown up in parking lots, and I've always wondered about the validity of those of the audit trail of your sample through those labs to reports back. I mean, when you centralize like this, it's very difficult to audit those databases, and there's privacy issues. We don't know these are going to turn into DNA banks or, what information is getting relayed where. So a lot of HIPAA got thrown out the window this year. And, I know when I've been tested before, I've gotten calls from my Department of Health here in town kind of harassing us not to go out. And I was like, how'd you get the information? How'd you even know that I was tested?
Yeah.
But
right.
that sort of thing, I think there are some societal things that would, like privacy in general, would be better if it were at home.
Sure.
And I think that would appease many more of the folks who are worried about the civil liberties in this.
Yeah. Well, longtime listeners will recognize, and I'll make sure I link to it, my HIPAA episode I did, where basically HIPAA does everything but protect your privacy. The whole point is actually information sharing with people who want to purchase it, which is actually just makes it more streamlined and simpler for them, whether it's scientists, laboratories, or whatever. And I think a lot of the problem that the FDA is driven a lot by the professional societies and by the hospitals too. So the hospitals obviously want to capture all those lab charges that is going to happen for testing, and also physicians too. As physicians are really hesitant to allow people to test anything. It's if you're old enough, that you couldn't actually buy an over-the-counter pregnancy test until relatively modern history, right? Because you feel like, well, I don't know if you pee. Can you tell if that's a minus sign or a plus sign? Right? I mean, right. And so those things existed. And so you can see why there is definitely a bias towards preventing people from taking care of, their own testing.
Well, you bring up an important point that regulation actually inflates the cost tremendously.
Yeah, sure.
So the PCR tests here are like $330, and those tests, same type of tests run in a market that isn't clinically regulated like this, are like $5.
Sure.
And in fact, I know people who run PCR at these volumes, and the cost when you get into it of the enzyme and everything else, it gets down below $1 when you start going up to these scales. There's a massive upcharge for the CLIA overhead. That probably brings it up to about $50 at scale. I think if you go to like one of the larger labs in the country is the Broad, and they're probably somewhere between $40 and $50 a test. And when you get to some of these more remote clinics and you're only doing one by ones, you're not bringing in hundreds of samples in every given batch, and the batch size is individualized, they go up to $150 to $300 a test. And none of that is really PCR costs. That's, I think, all regulatory costs. And
sure. Yeah.
So that's one downside of hyper-regulation, is that it does tend to drive the costs up. And I'm not certain you get the quality, quality per dollar spent is not necessarily great money spent there. They may bring in some more oversight and some more with some regulation. You might get, some more check boxes marked, but you're going to pay exponentially for it.
Yeah. I mean, you could argue really, I guess we don't know the answer as far as when you're infectious, how much viral load do you have to be spreading it? We can guess, if you have a lot, you're more likely to.
I've seen papers that suggest it's over, you need to have over 10 to the 6, 1 million copies per swab, and then you're more infectious than others. But, I think that's also tissue dependent. Like in the nasal pharyngeal cavity is a little bit different than saliva, than a bronchial lavage, than fecal sample. So there is some variance there, but I think, that's an area that I think is where the biggest optimization could occur is in nailing who's infectious with PCR or with rat tests, because the rapid antigen tests, because that sharpens who's negatively impacted by positive tests that aren't infectious.
You could even say we'll be okay with a lot of false negatives if we're catching, because if we're having everyone who can test at home,
you can do it multiple times,
daily or whatever.
Yeah,
I mean, it'd be a lot simpler, and then you're more likely to stop any sort of massive outbreak or spread if people can just do it at home.
Yeah,
right?
It is. You don't have the headache of having to go in and wait. And actually, you brought up a really good point. I think there's a lot more false negatives than people may know. Everyone's talking about false positives because nobody likes this, being falsely quarantined. But those swabs are known to have 30% false negatives. There's a lot of people slipping through on the swabbing front, and that just leads to what you're saying is we should have the ability to do this like every 24 hours if we wanted to. If it were a pregnancy test, we would have, they'd be like $20 instead of $200, and so you could take them every day for the course of your sniffles to know whether it's truly cold or whether it's coronavirus.
Yeah, I've talked to a surgeon just today, and I think he said he's been swabbed 24 times because he gets, exposed to times or whatever. And so, he's getting the nasopharyngeal, right? And he's like, I can tell when it's not a good one.
Yeah, it hurts.
He said, he said, I know when they're not up there. He said, when they're not scraping your brainstem, I know they're not far enough. And so I'm not, but to your point, that would definitely drive up the false negative rate, because it is not an easy test to test for. When to do a nasopharyngeal swab, it's pretty aggressive. And I felt like
I almost got a sinus infection, or I had pain for like a week after one of mine, but only only one nostril. They're really aggressive in one and not in the other, But they did go for both. They double barreled me, which was impressive.
I think we'll stop there, unless you have something else you want to add about the PCRs with the SARS-CoV-2.
Yeah, well, I would keep an eye out to address these questions. Some states are starting to put the CT values public. Rhode Island did this. Florida announced they're going to do it. I think that in general would help allay public concern over this, because you could track public dashboards, not just qPCR positivity, but where the CQs are globally on these. So you can see that, everyone's getting a lot hotter and higher viral loads and everything's going down. And it also gives you a sense if you have them per amplicon or per target in the test, you can see when the population starts to drop one out. And that's a sign. It gives you more epidemiology information about the scope of the pandemic. I think what happens right now with the tests is the scope of the pandemic gets broadened by the long tail of positivity. So, if all these patients can be positive for another 60 to 90 days, the pandemic's really going to be over probably in February, but it's not going to look like it's over until May. There's going to be a lot of people that remain positive for a longer period of time when the pandemic's really burning itself out. And that may, those 2 months of additional lockdown are going to have impacts that are just, I feel like that side of the equation is never really being spoken about. It's always about monomaniacal focus on the pandemic, and not really any care is being paid to the cost of our reaction to it. And I'm quite concerned about that, just seeing what the estimates on the long-term effect of this from cancer diagnosis.
Oh yeah. I mean, all the other testing that was delayed. I mean, I think only just now have we caught up to all the MRIs that we delayed for 6 weeks in the spring. I mean, because that scanner's running full tilt all the time. And so you slow down for 6 weeks, it takes a long time to get those back. And I think, to your point about false negatives, and, I guess the question would be like, well, how could you have a positive PCR COVID-19 swab, but not actually have it? And say, well, if you're not getting asymptomatic, but maybe you're symptomatic with like a regular cold, like we talked, like a rhinovirus, and now you get a PCR and you're positive. And so we think you had COVID, but maybe it's something else.
Yeah,
right?
That's the thing is this far as having so many people that are asymptomatic, there are co-infections in the data. I mean, there's really interesting work where they go and sequence all the RNA in patients, and they do find co-infections. I think 3% of the patients in Chris Mason's work had influenza A and influenza B and a few other rhinoviruses. And so you could be asymptomatic for SARS and have symptoms from one of the others. And that kind of confuses things. So I think that's important when we're thinking about viral therapies. I imagine on your end, you may need to know because, ivermectin is different than Tamiflu.
Sure.
You might, I don't think they've not been using Tamiflu. I know that early on they were playing around with that, but I think ivermectin's probably shown itself to be a more rational drug for C19.
Yeah, I'm just an intubation monkey, so I don't really do. I'm not doing clinical care
when
work.
It's too late to matter.
So I take care. So like I said, I took care of the guy who had appendicitis. He came in. He didn't know he had a SARS-CoV-2. He comes in. He's test positive, and he was. Let me tell you, there's no question he was actively infected with SARS-CoV because he had his saturation dropped like a stone on induction of anesthesia, which is typical of someone who's like really sick or something like that, or someone who's got a viral infection. Because I've taken care of people like the flu, and you do an anesthetic for them. For some reason, you can't avoid doing it, and they will desaturate, and they'll have, from a respiratory standpoint, they'll be more compromised.
Wow. He
did fine, and everyone, usually people do fine, but it can be, it can just be a little hairy.
Are there other differential biomarkers like D-dimer or, von Willebrand factor, or these other things? Are they specific enough to SARS that you can rely on those from the blood test, or
not that we use?
Yeah,
I mean, it's entirely possible that people are using things, but my understanding is that we just use the PCR test, really. And to your point about the qualitative, quantitative, if you show cycle times, all I know is that what the cycle time is for a machine, but I don't know. Do the labs actually get a value of what the cycle time was? Like, we saw it turned positive at 23. And so they just never report that, but that's something they have internally in their labs. So they could say, here in Grand Rapids in the last week, our cycle times for positives is about 22 and a half. And then 3 weeks ago it was 28. So it's getting worse.
Exactly.
Is that what you're kind of saying?
The machines will come in defaulting to collect at least 40 cycles, but usually the labs set the algorithm to, all right, call anybody under 37 positive, for example. Even though they're going to read the machine out to 40 cycles, they're going to call. And the reason for that is you get, when you start to get a curve from PCR, it is this, it's literally like, you've probably seen these kind of logarithmic curves, and you need a couple cycles after it crosses the baseline for you to actually measure the slope of that curve. So something at 37 doesn't finish arcing off until 40. And you want to see that whole arc so that you're confident it's not just some weird noisy spike. So they'll read them out longer than where they're actually going to call them. And ideally, they shouldn't be calling them past their limit, their measured limit of detection, which is attached to the assay. And I think the WHO just put out some guidance to make sure people are paying attention to the LOD on their test, because they do vary. And some people, if they just blindly set at 37, it won't transfer to another test as cleanly. But yeah, so you could see that on population scale if they're reporting those. They usually just translate that information to plus minus and give it to the state. But Rhode Island's gone to the point of like, well, let's scrape all the CT values up to the public dashboards so that we can chart those. And it's really interesting. You can see the segregations of the population that are what percentage. I think in Rhode Island, it was something like 40% of the people were above 35. And that's 35 is a number that Fauci brought up as being probably, everything after it's probably dead virus. So that, 40% of the people are dead virus. Maybe they shouldn't be quarantining, and maybe they could take a second test, right? You get past a certain CQ, double check it with something else before you go contact trace everybody and lock them down.
Well, Kevin McKernan from Medicinal Genomics, thanks so much for being on The Paradox.
Thanks, Eric.
As a reminder, today's sponsor is the Alpha Coaching Experience. Act now to claim your spot in the spring enrollment before the doors close on February 22nd at midnight. There's no better time than now to make the change you know you deserve to be a better parent, partner, and physician. Enroll today at drpodcastnetwork.com/alpha. That's drpodcastnetwork.com/alpha.
Thanks for listening to The Paradox. If you like what the doc is doing, please subscribe and leave a review on iTunes or Stitcher. And share the show with your friends. Become a supporting listener to get access to special bonuses at patreon.com/The Paradox. Show notes can be found at theparadox.com.